Hi, Viper Chemistry students. Hey, let's see if we can solve a mole problem here, mole ratio problem. Um, so we'll get things kind of set up here and try this on the board. All right, so what we have here up on the board, as you can see, get this sort of centered here. How about that? Okay, so what we have here is a combustion reaction. We have C3H8 and it is reacting with oxygen. So that's a combustion reaction. It's going to produce the products carbon dioxide and water. Now, that is not a balanced equation, so we'll need to balance that. But ultimately, our challenge here is to determine how many moles of water would be produced from or by 0.72 moles of oxygen. So that's kind of what we're up against here. How do we do that? So we have to balance the equation first. Now we have 3 carbons here and 8 hydrogens over here as reactants. So we might work on that first. We can try a 3 here, and that kind of balances our carbons. And then if we put a 4 here, let's see if that works. Okay, so if we put a 4 there, that's going to give us 8 hydrogens, 3 carbons. So we're good there. Now, if we look at our oxygens here, 3 times 2 is 6, and then 4 more would be a total of 10. We put a 5 here, that's going to be a balanced equation. Okay, so that looks like that works out for that. Now, how do we solve the problem? So what we want to do is start with what we know, and that is the 0.72, and the unit for moles is just MOL. Okay, so, and that's 0.72 moles of oxygen. So that's what we know going in. Now, what we have to do is use a conversion factor here. And that is the ratio, the mole ratio of what we're looking for, which is water to oxygen. Okay, so what is the mole ratio? So for every 5 moles of oxygen, there's 4 moles of water. So that's where we start with our conversion factor here, because we're looking for how many total moles of water would be produced from this amount of oxygen. So our mole ratio in a balanced equation is 4 to 5. So this would be 5 moles of oxygen gas. So where we're getting that is from the balanced equation. So we have we have a coefficient of 4. Our ratio of water to oxygen is 4 to 5. And that's called a conversion factor. Now we want to set it up this way so that in the end, when we solve the problem, we end up over here with moles of water. Okay. Now we set it up this way so that we can cancel our units of oxygen. That's so when we're doing this conversion factor, we literally are dividing by that, and those units of moles of oxygen would cancel. Okay, so that's the reason we use the conversion factor that way. Now, if we do the math, 0.72 times 4 divided by 5, if you just crank it out on your calculator, that ends up being 0.58 moles of water. Now, so the beauty of this and the tool that chemists use here is getting to where, like, if we know the formulas are correct, we know the balanced equation is correct, then now chemists can start predicting amounts. And so, like, this is a simple thing where if we knew this was the amount of oxygen, a chemist might know that in his lab or her lab, and then we could then determine how much water we would get out of that. It becomes very useful tool. Okay, so I hope that helps, and like always, keep working hard, and I'm glad that you had a chance to look at this. If you have any questions, let me know.